we go. Okay, I will make this bigger so everybody can see. I will start with Helidon using the Helidon command line tool. So I have downloaded it. I have Helidon command ready here. So what I will do first, I will do Helidon init, which will create a new project for us. We'll start with Helidon Microprofile. And because I want to show how to do stuff in there, I will just choose the second one, which is a quick start. It contains a couple of resources that we can use and demonstrate features on it. I'll just leave the defaults here and let's wait until we get our project. So I will not start a development loop. I want to show the project in IDE first. So I will open the project. And as it is loading, I will start the development loop. So I will do Helidon dev. And what happens now is that the project is being compiled and started. And whenever I do a change in the source code, I will get the new version. So we can immediately see what is available in Helidon MP when you start an almost empty application. So there are a couple of endpoints that are always available if you use the full microprofile. First of them is the endpoint for metrics. So let's have a look on that. So we have 8080/metrics. We can see it provides quite a lot of information about metrics of the server. The format that you see in front of you is actually Prometheus format. There is also a format that is using JSON. So we can request JSON format, and you can see that there is a set of vendor metrics, which are the metrics provided by the Helidon team. And there is a set of base metrics which are required by the specification. So if available, they need to be provided. There is also a set of application metrics. We don't see them because right now I don't have any application metric enabled. What is interesting here, you can immediately see the list of REST requests that are related to our JAX service resources. I will get back to that in a while. The second endpoint that's available immediately is the health endpoint, which is intended for Kubernetes or other tools that are interested in the health of your application. They are split into two. There are the liveliness health checks, which may tell you whether your application is up and running and alive. And there are readiness health checks, which we don't have by default, which gives you the information about if your application is already ready to accept requests from outside. And that's very important, especially when it comes to Kubernetes or other management tools. If you start a new instance of a service, you don't want to redirect traffic onto that service until it is actually initialized and up. So that's why we have the readiness health check. And then whenever you report that your service is down, and I was quite fast when I went through the liveliness health check, so let's have a look in detail on them. There are things, for example, like deadlock health check, and this actually detects deadlocks in your Java virtual machine. So obviously, if you have a deadlock somewhere, you probably don't want to get any more requests because your environment is basically down. So in this case, Kubernetes receives this information. It will shut down your container and start it again with a fresh new instance that will hopefully stay up longer. The next endpoint that is available out of the box is the Open API endpoint. Of course, not under health, it's under API directly, which gives you the what was Swagger before description of your service. So you can see that there is, we see a service that is /greet/greeting, which has a put request where you can provide a custom new greeting that will be that will return either a 204 when it was updated, or 400 if your request was bad. So this is a very nice description of your service that can be used by tools to automatically generate test payloads and so on. So these are the endpoints that are automatically available. Then, of course, is the application, the actual business logic that we have, which right now, as you can see up there, is on /greet. So when I execute /greet, we get the hello world, the classical hello world example. Of course, I can do a customized path that will just say hello to whatever the path provides. So you can see that the quick start already contains quite a lot, and now let's have a look into the source code, what was created and why. So I will start with the POM file. We are starting to support Gradle as well. The default is Maven. We actually use Maven in Helidon as well in the project. So what happened here? We have created a POM file that has a parent from the Helidon project. This is to simplify dependency management and plugin management. It is not required. You can use your own parent, in which case you will need to import the Helidon BOM or the Helidon dependencies BOM to enforce the same dependencies as we have in Helidon. If you use the parent, it's done. Everything is done automatically. Then we have a dependency on the Helidon microprofile, which is the bundle that contains the full microprofile specification in the version that we implement in Helidon. There is the Gendex for runtime. This is indexing tool used for the CDI implementation. So the startup is slightly faster. We use that. There is a plugin associated with that as well. And then we have the testing library, JUnit 5. Jakarta activation is actually not needed when we run without modules, so we can remove that. Now, from the plugins, you can see there is the copylibs execution that we have defined for the dependency plugin, which will create the target structure in Helidon. So if I go to target, I would need to stop our dev loop for a while. So let me do that. I will just do a build. So let's do a package. So I want to show the actual libraries that are being created. So now we can see that there is a directory called libs, and this contains the full transitive dependencies of Helidon microprofile. There's a bunch of things. It's not that big. It's around 15 megabytes of data. The reason why there is a lot of libraries is because Helidon itself is very modularized. We are trying to keep the modules as small as possible, so you can pick and choose what you want to run in your production. So you can really create very lean, small deployments with Helidon. The second plugin that we have is the Gendex plugin. As I said, this is the one that will scan your class path and create an index for the runtime of CDI. The next files that we have in the root. So there is a bunch of Docker files. These are used for building your application into a Docker image. So the first Docker file will just create a standard Java Docker image. You can see it's using the slim JRE base image, and it will contain your application, and it will start the application using java-jar. That's it. We have the JLink Docker file that will create a JLink image, and it will start it using the JLink image. So this should provide you with a smaller footprint. You can see that it's using the stretch slim base image, so it's really, really small with just the part of the JDK that's necessary for our application to run. And we have the Dockerfile.native that will create a native image from your application, and that native image will be put onto Scratch image of from Docker, which doesn't have anything. It doesn't have in a command line. So probably for your production environment, you may want to have something more. This is the smallest possible deployment you can get in Docker. You will have a native image of your application and the scratch image from Docker. Then we have the application.yaml for Kubernetes. So if you want to run your application in Kubernetes, this is a base Kubernetes descriptor that you can use. So this is really to help you to bootstrap your environment. And now we can go to the source codes. Two things that are important in meta-inf directory of our resources is the logging.properties. We pick this up automatically. You don't need to do anything in your source code to pick up the configuration file for logging. Helidon uses Jwt logging because we want to minimize dependencies on third-party software. So, there is a logging framework as part of the JDK. We use it. You can, of course, switch to any of your favorite frameworks. There are bridges for Jwt logging. And now we are finally hitting a microprofile specification. So microprofile config, one of the parts of the specification is the definition that all microprofile config.properties in meta-inf directories on the class path will be picked up and the configuration will be created from them. As you can see, we have a few things here. We have app.greeting, which is our application configuration. We have server, port, and host, which is Helidon configuration. And we have metrics, REST request enabled true, which is another specification coming from Microprofile. This is the Microprofile metrics. And this allows you to enable the list of metrics I have shown for our endpoints. By default, it's disabled, so you don't see it. We have it enabled, so you immediately see something from your application in the metrics output. And the last file that it's not really that important is beans.xml. It's not that important because it doesn't have any content that's, you just can copy the same content to every single one. It is important from the point of view that CDI uses this to identify your application as a bean archive. So if you don't put it here, you will not be able to see your beans. And slowly we are getting to Java. So you can see the whole project consists of two resources, two files that have some business logic in them. I will start with the greeting provider. So this is a CDI bean that reads a configuration property app.greeting, which I talked about before. We can see it in our, I will show it again, in the microprofile config.properties. And it says it's hello, right? So initial value for this bean will be taken from configuration, but it is a mutable bean. So you can actually update this greeting. So for the lifetime of this bean, which is application scope for the, so it's the same as your microservice. If you update the greeting, it will be used until you shut it down. When you start it again, it will read configuration from properties again. Why do we have it? Because our JAX-RS resource that I will be showing right now supports update of your greeting. So you can actually put a new greeting that will replace the existing one. So JAX-RS resource, this specification comes from Jakarta EE. It's the same thing. We are actually using Jersey as the implementation of JAX-RS. The only difference that we can see here is that we have annotated our greet resource with request scoped because we want to have that instance valid only for one request. You can choose whatever you want. You can also choose application scoped, but you need to be aware that the same instance would be reused by every single request. So you need to take care of things like concurrency when it's done that way. So as we can see, we have a /greet path, and then we have a couple of methods. So there is the get method, which is on the /greet, which returns the hello world. We have a method that will take the path parameter called name and create a greeting for that name. And then we have the put method, which has a bunch of annotations. These are related to OpenAPI. So this is the part we have seen in the YAML output of OpenAPI's endpoint. So as you can see, this is the update greeting that will use the bean. I will go back a bit here. JAX-RS on its own does not support the @inject annotation. This is coming from CDI. We can mix and match CDI and JAX-RS annotations in Helidon. We do prefer to use @inject because that's the CDI's way. You can also use @context, for example, if you need to inject headers or some other JAX-RS specific things that can be injected. All right, so that was the structure of the project, and now I want to start modifying it a bit. So I will start first with creating a new health check. So we have seen that there was no readiness health check, so let's create one. So we can see that there is an annotation called readiness. We will also mark this as an application scope bean. So there is one instance for our whole container, and we will implement a health check. As you can see, you just need to implement a single method that will make sure that the resource you are testing is valid. As it is a CDI bean, you can inject stuff in here as well. I will just create a simple response that will return up, let's say, 10 seconds after we started. And I will do it actually different. I will make it 10 seconds after we call it for the first time, because CDI beans are lazily initialized, and I don't want to create an application listener right now. So I will just do, I'll just store the current time in milliseconds of the first call. I will initialize it with 0. So here, if it's 0, we will just say it's null. And then, if the difference is bigger than 10 seconds, we will return that we are up. So now let's just do it this way. I could use duration and stuff like that. It's slightly more complicated. I will just work with milliseconds for now. So let's say that if the current millisecond time is more than 10 seconds after the first initialization, we will return up. So we will say health check response. And let's do, does this return a builder or response? So we want to do a builder. We will say that it's up. And we will say some data here. So let's just send in the actual difference. So I will just create this uptime, and I will call it uptime here, and send it as a data. Let's make it slightly easier. So we will just say that state is depending on the time, so I don't need to build the same thing twice. Okay, so we have an uptime. Then we check that if the uptime is bigger than 10 seconds, we are up. If it's not, we are down. And now we should be able to test this. So I will just run this again. I hope I have done everything right. And now let's see what is our health check doing. So as we can see, I managed to do something bad. We got an exception. Did I forget to return something? So let's have a look. Readiness 24. I forgot to add a name. Okay, so we can see uptime is now 0. Now it's 3 seconds. We will get there eventually. 10 seconds seems like a short time. Oh, and it's up. So this is just a simulation of such a process in your application. But in general, this will, for example, test a database. So if a database starts in the same pod as your application, you don't want to start accepting requests until the database is ready. So you would just do a database check, and eventually when the database is up, you would return up. So very simple health check edit. Don't forget about the name. The next thing I want to show is adding a metric to our application. So I'm going to update our greeting. And let's say that for the default greeting, I want to add a metric which is called simply timed. And simply timed is a metric that just calculates the overall time taken to execute this method and divides it by the number of executions to give you the information about how long it takes to execute a single invocation. So let's request our metrics. I'll just do this. And now we can see that there is an application metric that is using the resource class name and the method name as its identification. So you can only have one metric on a method. If you want to have more than one, you need to give them explicit names. And we can see that the count is 0 and elapsed time is 0 as well. So now I will just execute the default endpoint. Let's see a few times, and then I will ask for the metrics again. And now we can see that it was executed 5 times, and the elapsed time is really, really short because one invocation is, in microseconds probably in this case. So that was adding a metric to our application. Let me do a quick time check. And the next part that I want to show is tracing. So tracing is a very useful feature for microservices because in most cases your microservice is not standalone. You usually connect to other microservices that together form one response that is then sent to the front end. It's very hard to find out what's happening unless you have something like tracing. We do not implement a tracer server in Helidon. We implement the capability to connect to it. One of the tracer servers that can be used, for example, is Jaeger tracer. So let me just open my browser. I will prepare it off screen and I will move it so you can see it as well. So Jaeger tracer. Let's get here. So I have a Docker image running with Jaeger on my computer, and right now there is no service because we didn't connect our service to this tracer provider. So now I will do that in Helidon. So the thing that we need to add, we already have tracing support because microprofile tracing again is one of the things that is supported by the microprofile covering spec. So what I really need to do is I want to integrate with Jaeger tracer. So we have a library called Helidon tracing Jaeger. If you add this library to your dependencies and its microprofile environment, this tracer will be automatically prepared. Now, the default configuration is correct for localhost and the default port. So I don't need to specify any configuration right now. I could, but we don't need it. So now our server should be restarted, and somewhere here we should see that we have created Jaeger tracer configured to localhost 14.268, which is the default port of the Jaeger tracer. So now if I invoke my application, and refresh the page here, we can see that suddenly we have Helidon MP service. So that's the default name of a service if you don't specify an explicit name. And I can find traces. And here we can see that there was a Helidon MP service, which is 7 spans. So each span is some operation that is happening. So in our case, we have a covering HTTP request span that is from our HTTP server. You can see that the URL, the status code that was returned, and so on. Then we have security spans. Again, security is part of the microprofile implementation. If you don't want security, you can actually use the microprofile base bundle that will not contain it. So we have authentication and authorization. Then we have the JAX-RS invocation. In this case, it's again the localhost 8080/greet. And then we have a response from security. Again, security is validating the response. And we write the content on the web server. So if this was a collection of services, we would see a similar icon here for the other services that are in this trace. And the trace would contain the transitions from service to service. So if something fails, you would see here that there was an error, and you could actually troubleshoot it. So I can simulate it. Let's just throw a new runtime exception. I'm doing 1 = 1, so I don't have to comment out my return statement. And now if I do a greet, we can see that I got an internal server error because I did something that's not really nice to my application. The good thing is that you see it here immediately marked as an error. And when we get here, we have a log, and the log will tell us that there was an error, that an error occurred. And the same thing. Actually, here we see much more. We can see that it was a 500 response, meaning that this one was an internal server error. Of course, you need to still have your logs to be able to identify what exactly went wrong in your application. So again, you can see that it was really easy to add tracing to our application. You can also add an additional trace. So for example, let's say I'm interested in how much time is spent on the get message in my greeting provider. You could also say the operation name. So the Boolean value gives you control whether it is a traced method or not. And the operation name gives you the possibility to do a custom operation name. So let's say that I want to say this is a greeting provider message. Similar to what we would get anyway, but let's do it. So now, when I go back and search for traces, we can see that we have 8 spans instead of 7. We have added a new trace. And we can see our new span saying here with the name I have provided in the annotation. And you can see that the duration was 0.02 milliseconds for the initial request. So as we log 100% of requests now, we can see everything. So if you do it again, you can see that it's getting to unmeasurable amounts because the initial request always takes longer. So we can see here that the initial request was 83 milliseconds because that was caching all the stuff in Jersey, and the subsequent request was just 4 milliseconds. So it's really, really fast to do it, considering that it's doing quite a lot of things in CDI. Okay, the last thing that I want to show today is fault tolerance. So fault tolerance is something that is useful when you have a failing component somewhere in your infrastructure. So let's say that you are calling a third-party service and you know that that service is sometimes failing. And I want to fix that. I want to do something about it. So let's say that our default message could fail. Obviously, that's not a very good example because that really shouldn't. I will just put back our runtime exception. So here I want to have a fallback in case this is failing. And I want to have a fallback method on the same class, which will be called default fallback. Now, the rule for the fallback method is that it needs to have the same signature when it comes to return type and parameters. So I will just rename it to the name. And here we would return something that makes sense for the caller. So for example, we could return a cached record. We could return data that we store in our database that may be stale, but at least we return some data and we don't throw an exception. So I will just create a response and I will call it failed world. So it's cruel world, and then we should just switch the greeting to goodbye. Okay, now I have created this fallback. Our dev loop should be running again. And here you can see that without any exception, we get a response that we have created ourselves as the fallback response, even though our service failed. So fallback is the first of the fault tolerance annotations. There are others that can be used. There is, for example, the circuit breaker. I just couldn't remember the word. Circuit breaker annotation is, again, useful for services that are failing occasionally. It works in a way that the circuit breaker by default is closed, so all the calls to this method will go through and will call whatever needs to be called. But if you have a certain amount of failures, which can be defined by percentage, so you can see that there is the fail ratio that you can define. So by default, it's 50%. So if 50% of requests start failing, and the threshold is 20, so basically it means that if 10 out of 20 fail, the circuit breaker will open. In that case, any request coming to this method will immediately throw an exception. This is, again, a very good protection measure, because if you have a service that is overloaded and you keep sending requests to it, it will stay overloaded forever and it will never return anything. So if you have a circuit breaker, you can just stop sending stuff there and the circuit breaker will protect it. And after a certain period of time, in this case, there is a delay unit and delay that you can use. So in our case, it's 5 seconds. It will try to send a single request. And if that single request succeeds, the circuit breaker closes again and starts sending all requests to the backend. So very useful feature. We have bulkhead. Bulkhead is a protection of parallelism. So it makes sure that only a certain amount of parallel requests go to the same resource. There is a queue, and if the queue is exhausted, we don't want help. Thank you very much. If the queue is exhausted, you will get an exception that the bulkhead is full and you cannot execute it. So again, it's a fail-fast measure. If your resource, backend resource, has to be protected this way, and you have more than the number of requests it can handle, you can actually send back things like overloaded HTTP code, making sure that the client behaves accordingly to that response. Another thing that is that can be used from the fault tolerance is asynchronous. Asynchronous allows for execution in a different thread, and that can be connected with timeout, where you can define after how long it should fail. Okay, so that's that was the list of the fault tolerance features. I think that I have covered most of the important microprofile things that we are using. I'm not covering REST client API because I don't have another service. How does it work? You basically get an interface that has JAX-RS annotations, and you can configure it to connect to a certain, a service that is outside of your environment, and you just call that interface directly. You will get the remote responses. So it allows you to use JAX-RS even for client calls. There is another spec which is called Jwt Propagation, which we don't also show here because that requires a Jwt provider, and that's used for security. So if you have somewhere a server that will grant tokens to your users, you can easily protect a service with that approach and extract the username and groups formed from the token and use them to protect your resources. So that was all about the microprofile example I wanted to show today. Maybe the last thing, we are using Java 11, so you can use the modern features of JDK if you use Helidon. And with that, I will give it back to Dimitri or Joe, and thank you for your attention.